So this x component will be vector A times cos theta, and the y component will be vector A times sine theta. Now you must be very clear about it. Whenever you have a vector whose magnitude we know and the direction we know, we can find the x component of that vector. If A is a vector that makes an angle theta with the positive x-axis, its x component will be A cos theta and its y component will be A sine theta. A very important concept. If V is a vector that makes an angle theta with the x-axis, then the x component of the vector is given by, can you tell me what that will be? The x component of the vector will be given by V sub x equal to V cos theta. What does V sub x stands for? The x component of vector V equal to V cos theta, and the y component of the vector is given by, how will I write it? It will be V sub y equal to V sine theta. Okay, let's move on. Let's now introduce the concept of unit vector. What is a unit vector? A unit vector is a vector of magnitude 1. That's why it's called a unit vector. So if you now take the x direction and the y direction, we can have a vector of magnitude 1 unit along the x-axis. That will be a unit vector in the x direction, and a vector of magnitude 1 unit in the y direction. That will be a unit vector in the y direction. A unit vector in the x direction is a vector of magnitude 1 along the x direction. It is represented by the lowercase I and normally italicized. That's the very often. Now sometimes I italicize it, sometimes I forget. But that is the normal way to write a unit vector. So what does I stands for? I is a unit vector in the x direction. I is a unit vector in the x direction. It is a vector of magnitude 1 in the x direction. In the same way, a unit vector in the y direction is a vector of magnitude 1 along the y direction. And we will represent that by the lowercase j, again italicized. So the lowercase j is the unit vector in the y direction. So tell me, if I give you a vector, say a vector v equal to 5i, what do you understand by that? I'm giving you a vector v as 5i. What does I stands for? I is a vector along the x-axis of magnitude 1. If you multiply that by 5, you have a vector of magnitude 5 in the x direction. Alright, what does v equal to negative 5i represent? This is a vector of magnitude 5 in the negative x direction. Okay, we will be using all these concepts as we go on. A vector of magnitude 10 units in the positive x direction is 10i. 10i. A vector of magnitude 10 units in the negative x direction is negative 10i. Now I think that those numbers have gone off the screen. So what does 10i represent? 10i is a vector of magnitude 10 units in the positive x direction, whereas a vector of magnitude 10 units in the negative x direction is negative 10i. So this is positive 10i, this is negative 10i. Okay. So 10i added to negative 5i. What is the sum of these two vectors? 10i added to negative 5i. It's very simple to add because their directions are along the x-axis. This will give you a positive 5i. 10i added to negative 5i is positive 5i. You see, vectors can be added easily if they are along the same direction. A positive x vector and a negative x vector can be easily added. Similarly, a positive y vector and a negative y vector can be added easily. Also, two positive y vectors can be added easily. What is 5j plus 2j? You see, 5j plus 2j. Let me see if I can draw that here. 5j is this, 2j is this. If you add these two, you produce a vector of 7j. So 5j plus 2j, you see, 5j plus 2j is 7j. So it's easy to add vectors that are in the proper x and y directions. 8j plus negative 2j is 6j. Alright, let's do a small problem. Find the x and y components of a vector v of magnitude 15 units in a direction 30 degrees. You have a vector of magnitude 15 units in the direction 30 degrees. We need to find the x and y components of that vector. This is our vector of magnitude 15 units, and it makes an angle 30 degrees with the x-axis, with the positive x-axis. The 15 unit vector makes an angle 30 degrees with the x-axis. I'm going to call its x component as v1. You can also call it v sub x. Let's call it v1. Alright, tell me, what is v1 equal to? What is the x component of this vector? v1 will be this vector, and that will be given by, well, let's also write the y component. If v2 is the y component, this will be v2. So this vector has the x component v1 and the y component v2. Alright, let's find the values of v1 and v2. You know, in this triangle, v1 divided by 15 is cos 30 degrees. Therefore, v1 equal to 15 cos 30 degrees. And sine 30 degrees is v2 divided by 15. Therefore, v2 is 15 sine 30 degrees. So the x component of the vector is 15 cos 30 degrees, and the y component is 15 sine 30 degrees. The magnitude of the x component, now this is the magnitude of the x component, 15 cos 30 degrees. If you want to specify that this is in the x direction, what all you need to do is multiply it with the unit vector in the x direction. What is the unit vector in the x direction? The lowercase I. Alright, to indicate its direction, we multiply this vector with the unit vector I. Therefore, the x component is 15 cos 30 degrees I. Look at this, a very important information. A vector of 15 units at an angle 30 degrees with the x-axis has an x component 15 cos 30 degrees I, and what is the y component? The y component will be 15 sine 30 degrees j. And therefore, look at the way we write that vector v. If this is the vector v we have, this vector v is now written as the sum of its x and y components like this. It is 15 cos 30 degrees I plus 15 sine 30 degrees j. You can see I have forgotten to italicize these. So any vector that is given to you can be written as the sum of its x component and the y component. Okay. Now 15 cos 30 degrees is approximately 13. So this will be 13i plus 7.5j. You see, 13i plus 7.5j, you must understand it as, this is 13i, a vector of 13 units in the x direction, and this is 7.5j, 7.5 units in the y direction. So this is the x component, this is the y component, and if you add these two, you get the vector v. And what is that vector v? The vector v is joining the vector like this. Now, you see, a vector has a tail and a head. This is the tail of this vector and this is the head. For the second vector, this is the tail and this is the head. So once you have the components identified, to find the resultant vector, what all you need to do is join the tail of one component to the head of the second component. And this is the vector v. Alright. Now, I can actually use this to add any number of vectors. For example, if this is one vector and this is the second vector, I'm going to call this vector v and the second vector u. Now, can you tell me, if this is vector v and this is vector u, what will be the sum of these vectors? If you add these two vectors, what will be the result? The result will be the vector that is obtained by joining the tail of the first vector to the head of the second vector. Now, this is the sum of u plus v, and that is called the resultant vector. You see, actually this law is called the triangle law of vectors. If you got two vectors given by the two sides of a triangle in order, then the third side drawn in the opposite order will represent the resultant of these two vectors. Now, we will deal with more of triangle vectors in the lab part of this. At the moment, I'm going to leave this here.